This conference will now be recorded.
Very good evening, students. We are back with an important topic in the ray optics chapter. So today we are going to discuss refraction of light through prism. So from this portion, generally a good weightage of questions come in various competitive exam like NEET, JEE and board exam as well. So let us understand this topic properly, and obviously we will have discussion on numerical problems and how to solve them at the end of the session. So refraction through prism. Before we go to the topic, let us learn what is called prism. A prism is a oval-shaped portion of a transparent refracting medium bounded by two plane faces inclined to each other. See, from this figure, with respect to this figure, if we define what is a prism, you look, this is actually a transparent. First of all, this is a transparent material. Prism is made of transparent material. Most of the cases it is the glass. Okay, the material is the glass, and we'll be having in our laboratories, most of them are made of glass prism. Okay, so sometime it is said plain glass prism. Okay, so it is actually a Y shape. You can see, if you just see the three-dimensional figure, so there are two faces at this. So these are two triangular faces. If I name it, let me just name these vertices. This is A, suppose. This is B. This is C, and this is D. This particular vertices is E, and this is F. Okay, so there are actually 5 faces. If you look, there are 5 faces in this. So this is a typical prism. Okay, so there are 5 faces. I'll just name the faces. So there are 2 triangular faces. Triangular faces, you can easily find out them. Sorry, triangular faces. There are 2 actually. One is ABC and another one is DEF. Okay, these 2 faces are there, and 3 plane faces are there. Okay, plane faces. 3 plane faces. One is ABED, ABED. This slanted face. This one. Okay, this one. This face. This slanted face. Okay, ABED. Another face is, see the just other this ACFD, other one ACFD. So this is this one. Okay, this one. All right, this face, and then the the face BCEF. This is actually called base of the prism. This is generally this will be non-transparent phase. This will be non-transparent. It will not be transparent. Okay, anyway, so this is called base. Okay, the AD is called the edge of the prism. You look here, edge of the prism, and two lateral faces are there. Two lateral faces, as you see. So this ABED and ACFD, these are two lateral faces. Base is this one, BCEF. Okay, and see these triangular faces are also there. So the line AD along which the see these two faces are actually the lateral faces. Lateral faces ABED and ACFD. These two are actually refracting faces. Light refracts through these two faces. Refracting faces. These are refracting faces. Refraction happens through these two faces only. Okay. Now, if we take a cross section of this, we'll get a triangular shape, right? We'll get a triangular shape. Triangular. So that's why whenever we'll be drawing a figure of prism, we'll just draw a triangle. Okay, that means we are taking the triangular face. So this triangular face, see AB and see AB face. So AB line, if I say this is AB, so AB is one face through which the light enters, and AC will be the other face through which it will be transmitting. Okay, transmitting. So AB and AC faces will be refracting faces. AB and AC. Okay, for a triangular prism when we will be drawing. So you can understand that it has 5 faces. Among them, one is base, other two are lateral faces are refracting faces, and these are triangular faces. Okay. Now look, the angle subtended by or the angle between these two faces AB and AC, or these two refracting faces ABED and ACFD. F, this is F, this is E, ACFD. The angle between these two refracting faces is called actually angle of refraction. Sorry, angle of prism. This is called angle of prism. This is generally denoted by A, angle A. Okay. So A is the angle of prism. Angle of prism. A is the angle of prism. Okay. Now, any section of the prism cut by the plane perpendicular to the refracting edge. Refracting, this is AD is called refracting edge. If I just cut a face or a cross section, that will be called as principal section. And that principal section will be of triangular shape, as I was talking. Now we'll be trying to understand the angle of deviation due to this refraction. See, you know this is air. When a light ray enters into the other medium, this is glass, right? Prism is glass. So here actually we are just assuming, or we are taking a principal section here. Okay, as I said, AB phase is one of the refracting phase, and other one is the AC phase. I can use any of the phases for like to take as. Okay, so what I'm trying to do is I'm just uh, doing the experiment in such a that the incident ray is refracting at AB interface. I'm just taking now. And then the light ray enters into the prism and refracts on the like from the other surface AC, and eventually the light ray emerges out. Okay, so you can see what we are going to do now. See, we are going to derive now the expression for the angle of deviation. What is angle of deviation? Before I explain what is the angle of deviation, let me just explain this figure. So as I said, we have taken a principal section ABC, okay, or triangular shape, right? So AB is one of these two refracting surfaces. So AC is the other one. Now, if light ray enters or refracts here at AB phase, okay, look, this is the angle of incidence, and you can see this is this dotted line is actually normal to this AB surface, and here this dotted line is actually angle normal to the AC surface or AC yes, AC surface. Okay, so always angle of incidence will be calculated or measured with the perpendicular to the interface, okay, or the normal to the interface. That is what it is done here. See, the ray PQ is the incident ray, and the angle of incidence is this. Okay, so I'm just trying to write. See, for AB phase, if we just consider the refraction at AB phase, so angle of incidence is this. So in this case, actually, we can write. See, if we write the Snell's law, mu1, so mu air angle sine of I is equal to mu r, sorry, mu glass or prism, let us say mu g sine r. So mu a is air, that is 1. So mu g, which is the sine a by sine r. So that is the refractive index of the material of the prism. So we have to, in general, we have to find out this mu in terms of angle of angle of prism A and delta, and known thing is this angle of incidence. So in terms of these three, generally we need to, or yes, so in this angle of E also may come anyway. So in terms of these parameters, mainly A and D, angle of deviation and angle of prism. In terms of these two, we have to find out the refractive index of the material of the prism. Okay, so this is generally in the laboratory we have to do. So what is this angle of deviation? Angle of deviation is actually denoted by delta. What is deviation? Deviation means, suppose my light is coming like this. If it goes like this now, so let us say this is A, this is B, this is C. So at the point B, light got deviated. Okay, what is the angle of deviation? So angle of deviation will be, say, measured with respect to the incident ray. See, the direction of incidence is this one, right? Direction, if I just extend, this is direction of incidence. Now the light has got deviated, okay, BC. So this angle between the direction of incidence to the direction of the deviation or deviated ray. So this angle is actually generally denoted as delta. So what will be the angle here? See, in this case, angle of, see, the direction of incidence is this one, and the ray has actually deviated when. So as I said, light will enter to the prism and then it will emerge. So this emerged ray or emergent ray, and the direction of angle of deviation, the direction of the direction angle between the direction of incidence and the emergent ray. This angle is actually called delta. Here in the figure it is given. See, this is the angle of deviation, this is delta. See, this is the direction of incidence and this is the ray, emergent ray. Okay, so direction was earlier here, so its angle of incidence was this, but now it has deviated to this direction. So this is the angle of deviation. Okay, now we have to find out expression for the delta. The delta can be found out in terms of I, R, or A, something like that. Let us try to find out the relation. Okay, so to find out, let me just erase these things. To find out, we will be using our geometrical knowledge. Okay, geometric knowledge from geometry. See, we have a quadrilateral in this figure itself, quadrilateral AQNR. Okay, so from this quadrilateral, what we are going to get? See the angles. See, angle of prism is A. Okay, plus QNR, or let us say this AQN angle, then angle QNR plus angle MRN, sorry, ARN. Okay, the total of this will be 360, isn't it? Quadrilateral means. Now look one thing. See this angle AQN, this angle is 90 degree. AQN. Why? Because this QN is actually perpendicular to the AB, because this is the normal to the surface AB. So that's why QN is normal. So this angle will be 90 degree. Okay. Further, look this ARN. This angle also will be 90 degree. ARN. ARN, because this is also perpendicular, right? NR is perpendicular to AC. That's why. Okay, so that's why this total angle is 90 degree. Okay, so we have got this two 90 degrees, this angle and this angle. So the left of them, like, see, others are, so the sum of angle A, then we can say sum of angle A and QNR. these two angles, sum of these two angles must be 180 degree. Okay. Now see, from triangle, triangle, this uh, QNR, QNR, these two triangles. So these triangles, so QN and R. Okay. Okay, one more point I just forgot to tell. We have to see one more triangle. If we see the triangle, okay, let me write this QNR itself. Yes, QNR. Okay, this is fine. Okay, so this is fine. So QNR, the triangle, this QNR, this one is the triangle. Now from here, look what we get. This triangle, see, R1 plus R2. These are angle of refraction at this AB and angle of incidence in the AC. So these two angles are there, and plus this angle QNR. QNR. This, since this is a triangle, so the sum of them will be also 180 degree. Sorry, yes, 180 degree. So this is suppose equation number 1 and this is equation number 2. Just compare these two, what we get. Comparing 1 and 2, comparing 1 and 2, we get, see, Q and R is common for both of them. So R1 plus R2, okay, R1 plus R2 will be equal to A. So this is, so this R1 is actually angle of refraction at the face AB, and R2 is the angle of incidence for the face AC. And look here, what you can do is actually, if we just reverse the direction of this ray, it must retrace, okay, the same path. In other words, we can do this experiment from this side also. We can send the light from SR, okay, it can be just reversed as angle of incidence, then this will be angle of emergence I, sorry, E. Okay, all right. So this thing we have got now. Now we have to find out the angle of deviation, right? So angle of deviation, let us write what is delta. See, delta means this triangle. If you see MQR, see this triangle, you see MQR. MQR, this triangle. From this triangle, you can write the delta to be the external angle for that triangle, right? So delta is equal to this angle plus this angle. Okay, let us see what we can write that. See, this whole angle, you know, this whole angle is how much? This whole angle will be actually I. Okay, so this is I minus R1, means this particular angle. Okay, this is I minus R1, and this side again, this particular angle will be E minus R2. Okay, actually this angle delta, is external angle to this triangle MQR. From there we can write, I have just messed it up here, let me show you. So this angle, so delta means sum of these two angles. Okay, I'm just calculating these two angles in terms of a known angle. So this whole thing is I, but see, I minus R1 means this particular angle. Similarly, E minus R2 means this particular angle. So this is what it is written here. Look now, this equation gives you okay. So from here, see, this is equation number 3. From equation number 3, if we write this term as A, then what we get? I plus E minus A. Okay. So A is the angle of prism, E is the angle of emergence, and I is the angle of incidence. Okay. Now we have got, so this formula, say I can write this as I plus E is equal to delta plus A. Okay, so look from here, I'll just show you I plus E, this means angle of incidence plus angle of emergence, that is equal to angle of prism plus delta. Angle of deviation plus angle of prism. Okay. So when a ray of light is refracted through a prism, the sum of the angle of incidence and the angle of emergence is equal to the sum of the angle of prism plus angle of deviation delta of the light. Okay, so this formula or this is fine so far. Now we'll try to understand what is called minimum angle of deviation, and one more thing we'll just discuss about see the factors on which the angle of deviation depends. So we have already come up to here. So where we have got I plus E, that means angle of incidence plus angle of emergence is equal to the angle of deviation plus angle of prism. Okay, so the factors on which angle of deviation depends on. So one is angle of incidence, angle of incidence. Then angle of prism, angle of prism. Wavelength of the light used, and the fourth is actually the material used to make the prism. Okay, so these are, So that means it depends on I, it depends on A, it depends on wavelength, lambda, it depends on mu also, material of the prism. Okay, these four factors are there. Okay, so let us try to find out what is normal, minimum angle of deviation, because you look here what it is. See, if we see this variation, okay, let me just erase these points. I'll write angle of incidence, angle of prism, angle of prism, and then refractive index, and wavelength used. So these are the four factors. Now here, if we just see, if we just vary angle of incidence, see for the case, so when the prism has certain particular shape, so this A is fixed. Now if I use a particular light, then this is fixed, and if I use only one prism, then see these three factors will be fixed, only variable will be I. Okay, that means, you know, with I delta changes, with I delta changes, I versus delta. This is what big is being plotted in this particular graph. So, delta, when delta is plotted, you look, when delta is plotted with respect to I, for a single value of delta, there are two angles. See, for a single value of delta, it is, if it is 50 degrees, there are two, actually there are two angle of incidence or emergence. See, this angle called angle of incidence, this angle is called angle of emergence. So these two angles are actually there. So we can see that for a particular angle of incidence, sorry, for a particular value of delta, for a particular value of delta, there are two angle of incidence, we can say, because angle of incidence can be treated as angle of emergence. Or in other words, I can say angle of incidence and angle of emergence are different. Okay, they have different value for a particular delta. For a particular delta value, there are two different values of E and I. But as we vary I, will see at certain point of certain angle of incidence. For a certain angle of incidence, the delta is becoming equal to minimum. Okay, this delta becomes minimum. For a particular value of angle of incidence, this is the delta, this delta becomes minimum, and you know, delta becomes minimum at this particular position, right? And you look there is only one angle of incidence, that means angle of incidence plus angle of emergence will be equal at minimum angle of deviation. Okay, so at minimum angle of deviation, angle of incidence and angle of emergences are same. Okay, and in that case, you know what will happen? The ray inside, See, at this ray will be actually parallel to base. Parallel to base. Parallel to base. Okay. So parallel to base means what? So at minimum angle of deviation, what are the things happening? This is the one point you can see at this particular position. So this angle of incidence and this angle of emergence, they merge on each other. Okay, what else? So again, R1 is equal to R2. Why? Because at minimum angle of deviation, the ray inside the prism will be parallel. So that's why these two angles will be equal. Okay, so these are two corollaries from this particular discussion: angle of minimum deviation. Now we need to find out the relation between refractive index and minimum angle of deviation. As you know, so if this is the prism angle of prism, sorry, refractive index of the material out of which the prism is made. So this means, you know, sin I by sin r, angle of incidence divided by sin r. Okay, so I have to find out what is I and what is r. At minimum angle of deviation, see, at minimum angle of deviation, so we had got few relationship with minimum angle of deviation. You can see that I plus e is equal to I plus e. We had a relation. You can just see that I plus a delta is equal delta plus a. So that means, you know, this is minimum, delta minimum plus a, angle of prism. Okay, since this I and e are equal at this minimum angle of deviation, then I. Okay, so what is I then? Okay, so this is actually the relation. So we have got I is equal to what? So I is delta minimum plus again R1 is equal to R2. So what we will do? Look, in the beginning we have done one thing, that R1 plus R2 is equal to A, equation number 3. R1 plus R2 is equal to A, okay. So we had relationship, that is delta plus A is equal to E plus I plus E. Okay, this we knew, and we knew this. Okay, now angle of deviation is actually, see, this from here we have got already I is equal to R is equal to what? So R will be, since R1 and R2 is equal to equal at minimum angle of deviation, this is minimum I should write. So this will be R by A by 2. So we have got I and R. So I is delta minimum plus A by 2, this one. Okay, so we have got an R. With R, see there was a relation R1 plus R2 is equal to A. From there we have got the angle of refraction. So sine I is equal to delta minimum plus A this is A by 2. Okay, so this part is done. I'm sorry, this sine R means what? Sine R means sine A by 2. So this is actually the formula for finding out refractive index of any prism. Okay, so we have got this formula mu is equal to sine of delta minimum plus angle of prism divided by 2, that is the angle of incidence, and then sine A by 2, that is the angle of refraction. So this will give you the idea, or you can, if you know the delta minimum for a particular prism, angle of prism for a particular prism, and as you said, wavelength of the light was taken fixed, and since the material is also fixed, then mu will be a single mu, and you can get from this particular value. Now if the angle of small angle is small angle, for the small angle case, small angle prism, delta is related to mu, delta is equal to A into mu minus 1. Okay, A into mu minus 1. Delta is equal to A into mu minus 1. So this will be for small angle prism. Okay. Okay. So this is for small angle prism, and this is originally. Okay. So from these two angles, these two relationship, we can find out actually the material of the refractive index of the material of the prism. Okay. Now we'll just try to solve at least one numerical problem first related to this prism concept. Okay, so here is a problem. I'm just writing on the board. Calculate the angle value of angle of incidence. Calculate angle of incidence when a ray applied when a ray of light incident on one face incident on one face of an equilateral triangle triangle equilateral prism, let us say equilateral prism, glass prism obviously, produces an emergent ray such that it gauges it gauges the other surface of the adjacent face, or okay, gauges the adjacent face. Okay, what does that mean? So suppose this is an equilateral triangle. So here it is given that mu is equal to root 2. Then what we have to calculate? We have to calculate the angle of incidence, this angle. So the question is that a ray refracted from this surface AB, and then this angle of incidence is made in such a that for this particular material where mu is equal to root 2 is see when this ray refracted, it is going through the AC face itself, grazing the AC face. Okay, I'm grazing the AC. All right, that means it is going tangential to the AC line. Now this angle of refraction is 90 degree now. Okay, angle of refraction at this place is actually becoming angle of refraction at this place will be 90 degree. Okay, because it is gazing right, this ray is gazing the AC surface. Now if we apply here Snell's law, okay, if we write Snell's law here, that means mu sine R2, this is actually R2, right? This is R1. Mu R2, this is mu AR sine 90 degree. So this gives actually, see, mu sine R. This actually gives, see, this is mu 0 is 1, sine 90 degree is 1. That means, you know, sine R2 is equal to 1 by root 2. Sine R2 means 1 by mu, 1 by, not sine, it is 1 by mu. So it is actually from here, I can write mu is equal to 1 by sine R2. Okay, so mu is given for this particular problem, mu is given. So mu is equal to, so this is what we have got, or we can write sine R2 is equal to 1 by, okay, this is equal to 1 by mu or 1 by root 2. This is the value for this mu. Okay, so from here we can easily get that this R2 is nearly equal to 45 degree. Okay, sine R2 is equal to 1 by root 2, so R2 is equal to sine 45 degree. So from here we'll get, see, now we'll just check refraction here. So we know AR, this is mu, mu sine R1. So sine I you have to find out, this is AR anyway, mu A, mu AR is 1. So mu is equal to sine I by sine R. So this is mu is equal to this. We have to find out sine I. So we are not going to find out again mu, right? So sine I is equal to mu sine R 1 divided by this is, so this is the value we have to find out, and see mu is actually root 2 sine, this, okay, so sine R1 is equal to R2 at minimum angle of deviation. So this is, Right. So see, equilateral triangle, we have to find out what is R01. R01 is not given, so we have to find out R01. So what is R1? A is equal to R1 plus R2 at angle of minimum angle of deviation. So R1 is 45. See, this will be 60 degree minus R2. R2 is 45 degree. So this will be actually 15. Okay, this is actually R1, 15 degree. So sine 15 will come here. So this will be root 2 into sine 15. Okay, if the value is known, then it is easier to find out I. Okay, or otherwise you have to take the use of calculator. If this value is given, then it is easier to find out what is sine I, because now I will be sine inverse root 2 into sine 14, sorry 15, sine 15 degree. Okay, angle of incidence we have to find out. Okay, so I think we'll stop it here for today. Next day, we'll take a few more numerical problems from this prism, as well as we'll go for the instrumental part, that means the microscope and telescope. Okay, so thank you for your patience. Bye for today.